All right, today we will be solving multi-step equations with some variables on both sides. Steps when we are solving multi-step equations with variables on both sides. First thing we always want to do is distribute. Then we want to combine like terms. We want to get the variables on one side of the equations by using inverse operations. We also want to move the constants away from the variable by using inverse operation, meaning we want variables on one side of the equation and constants on the other side of the equation. And when we have that variable on that one side of the equation, we want to get rid of the coefficient by performing inverse operations. So my first example, we have 11 plus 2 plus 2p is equal to p plus 4. The object is to solve for the variable, but I need to get the variable on one side of the equation, but I have it on two sides of the equations. Well, I also have constants on both sides of my equation too. So I'm going to perform inverse operations because I want to move my variables to one side and my constants to one side. I can't just pick them up and move them because I want to. So we got to use inverse operations. So I'm going to move this p to the orange side. So I want it on the other side of the equation. How is p being over here? It's being added. So I'm going to do the inverse and subtract it. Notice if I subtract p from one side, I got to do it from the other side. Notice I didn't subtract p from 11. I didn't subtract p from 4. They're not like terms. Well, I didn't add anything to 11. So I'll just bring it down. So 11 plus 2p minus p is equal to p. Well, my p minus p cancel, and I just bring down my 4. Now p is somewhat over here by itself, except for this constant. So I need to move it to the other side of the equation. So I need to perform the inverse of this positive 11, which is subtracting it. Notice I didn't subtract 11 from p. Can't do it on the same side. Can't do it if they ain't like terms. Well, 11 minus 11 cancel. I just drop my p down, and 4 minus 11 is negative 7. All right, 3 plus 5n is equal to 2n plus 15. Again, I want my variables on one side of the equation and my constants on the other side. So since I want my variables on the orange side, that means I need to move this 2p that's on my constant side. How do I do it? By inverse operations. I can't just write 2p. If I write 2p, I don't know if I'm adding it or subtracting it. So the opposite of adding 2n is to subtract it. And if I subtract it from one side, do it to the other. All right. Bring down my 3 because I didn't do anything to it. 2m minus n, 2n cancel out because they're opposites. And I get 3 plus 3n, 5n minus 2n is equal to 3n, is equal to 15. Still trying to isolate n. What constant is over here with it? A positive 3. So the opposite of positive 3 is subtracting 3 from both sides, lining it up with the right terms. 3 minus 3 cancel out like I wanted it to. Bring down my 3n, and it is equal to 12. N is still not isolated. Now it's being multiplied to 3. The inverse of multiplying that coefficient of 3 is to divide it. Well, 3 divided by 3 cancels out, and I get n is equal to 4. Negative 7k minus 4k is equal to 8 minus 2k minus 8k. I want variables on one side and constants on the other side. But if I notice, I got 2 variables over here, 2 variables over here. Therefore, I've got to combine my like terms. My like terms on the orange side of the equation is a negative 7k plus a negative 4k. My like terms on the blue side of the equation is negative 2k and negative 8. So I'm going to combine the orange side. Negative 7 plus negative 4 gives me negative 11. And on the blue side, negative 2k minus 8k gives me 8 minus 10k. So I've combined my like terms. Now remember, I want my variables on one side of the equation and my constants on the other side. So the only way to do that is to add 10k to both sides. Well, 10 plus 10 and negative 10 are opposites, so they cancel. I didn't do anything to my 8, and negative 11k plus 10k gives me negative k. But notice that k is not isolated. It's not isolated because it has a negative 1 in front of it, that magic 1. So the inverse of multiplying negative 1 is to divide negative 1. Negative 1 divided by negative 1 cancel, and k is equal to negative 8. 2 times negative 6m minus 3 is equal to 6 times 5m minus 1. Got to get rid of these parentheses and this number outside of the parentheses. Therefore, I need to distribute. Distribute 2 to negative 6m and to negative 3. On my blue side of the equation, I need to distribute 6 to 5m and to negative 6. 2 times negative 6m is negative 12m. 2 times negative 3, negative 6. 6 times 5m, 30m. 6 times negative 1, negative 6. Now this looks like an equation that has variables and constants on both sides, but I want to move my variables to the orange side. So 30m, what's the opposite of adding this positive 30m? It's subtracting it. So negative 12 plus a negative 30m minus 6 is equal to 30m minus 6m. Negative 42 minus 6 is equal to negative 6. So 30m minus 30m cancels out. Negative 12 plus negative 30 is negative 42, and I did nothing with my 6's, so I can just bring them down. Now I need to move my constant to the other side of the equation. I do that by the inverse operation. Opposite of negative 6 is adding 6. They cancel out like I wanted them to, and I get negative 42m is equal to 0. Well, m is still not isolated because it's attached to negative 42. So the opposite of multiplying by negative 42 would be dividing by negative 42. Negative 42 divided by negative 42 cancel, and I'm left with m is equal to 0. Last example, good old fractions. X minus 3 halves is equal to 2x minus 11 halves. Y'all know my thing with fractions. I want to go ahead and get rid of them. The only way I can get rid of them is by multiplying them by the common denominator. What is the common denominator between these 4 terms? It's 2. So I can multiply every single term by 2. 2 times x, 2x, 2 times a negative 3 halves. Well, those 2's are going to cancel, and I'm left with negative 3. Well, 2 times 2x is 4x, and 2 times 11 halves, well, those 2's are going to cancel, and I'm left with a negative 11. Same old equation with variables on both sides. This time I want my variables on the blue side, just to show you that it doesn't matter. So I'm going to move 2x to the blue side by using inverse operations. So the inverse of adding negative 2 is subtracting it from both sides. Notice I didn't line negative 2x up under negative 3 or negative 11 because they're not like terms. Well, negative 2x minus 2x cancels. Did nothing in negative 3, did nothing to negative 11. So they get to come down for the ride. 4x minus 2x gives me 2x. Now, I need to move this constant from over here with my variable because I want my constants on the other side of the equation. So the inverse of subtracting 11 is adding 11. Well, that cancels. I did nothing to my 2x, and 11 minus 3 gives me 8. Still trying to isolate this variable that's being multiplied to 2. Opposite of multiplying by 2 is dividing by 2. And x is equal to 4.